Hi, welcome everyone. In this video, we'll discuss about interpolation and approximation. So the topics which are to be covered in this video are a brief introduction to the interpolation and approximation, and then Lagrange's interpolation formula. So to begin with, the question is, what is interpolation? The method of estimating unknown intermediate values of a function y is equal to fx for a given set of values of independent variable x is called interpolation. Okay. Consider we have a function y is equal to fx, but we don't know about the actual function fx. It takes values of yi at respective xi's are. For example, these are two rows. First is value for the value of x, and second one is for value of y. So x take values from x0, x1, x2, so on up to xn, that is n plus 1 values, and corresponding y's are y0, y1, y2 up to yn plus 1. Okay. So now, if the form of function is fx is known, then we can calculate value of y at any value of x. For example, if fx is equal to x square, we can calculate the value of y is equal to fx at any value of x. In most cases, function form is not known. Okay. For example, if you are doing certain experiment and you are finding that for a particular independent variable there is dependent value of function as well. So we have discrete values, but we don't know the actual functional variation or functional form of that data. So if we want to know the value of that function which is not known in between the values of an independent variable, then we can take help of interpolation. So in such a situation, a function phi x is required which has same values as of fx at different xi's. Okay, so and this process is called interpolation. If phi x is a polynomial, it is called polynomial interpolation, and phi x is here is interpolating polynomial. So what is phi x? It satisfies the condition that it will give you y naught at x naught, it will give you y1 at x1, so on, it will give you yn at xn, but in between it may have a different value as compared to that of fx. So this is an approximation. Now next is assumptions of interpolation. There should not be any sudden rise or fall in the values of the function or the data. The rise and fall in the values should be uniform, and given a set of observation can be expressed in polynomial form. So these are the prerequisite or assumption of interpolation. Now next is difference between interpolation and fitting. So there are two terms, interpolation and fitting. Suppose we have a given set of data, this one solid circle. On x-axis we have 5 different points, x1, x2, x3, x4 and x5, and y-axis we have f of x. This is shown in this figure. So we have given set of data. Okay. Now we'll differentiate up between interpolation and fitting using this set of data. The interpolation, this one, passes through each data point. So this is the interpolation. Then, and what is fitting then? In fitting, which is red line, a curve is produced that approximates the data. So it may or may not pass through the data. You see here, this is the curve. So it leaves the point, second point, and leaves the fourth point as well. So this is actually the difference between interpolation and fitting. Next the point is overall versus piecewise interpolation. Okay, so in overall, a single polynomial of degree n can be used for fitting n plus 1 data points, like this one. Okay, so this is a single polynomial. Alternatively, in between piecewise, what is meant by piecewise, that is in the subintervals x1, x2, and then x2, x3, x3, x4, and x4 and x5. So in between x1 and x2 we use different polynomial, in between x2 and x3 we use another polynomial, and so on. In piecewise, one can use series of polynomials to link the consecutive points together. This process is called spline fitting, like this one, this red line. So it is better as compared to the uh, overall fitting. So in this figure, linear polynomials are used for piecewise interpolation for the emphasis. However, in general, spline will usually be cubic polynomials to emphasize the piecewise nature. So the cubic polynomial has a better curve as compared to this straight line linear polynomial. Okay. For overall interpolation, we have Newton interpolation method, which is applicable to equal size of interval. There are forward difference method and backward difference method. Then we have Lagrangian interpolation, which is equally applicable to unequal size of interval as well. Then we have piecewise interpolation, and in this category we have spline interpolation, and particularly the cubic spline, and the approximation of method of least square fitting of data as well. So first we have the Lagrangian interpolation, and also applicable for interpolation with unequal intervals. So as I've already mentioned, let us derive the Lagrangian interpolation formula first. Let y is equal to fx takes following values of yi's corresponding to n plus 1 values of xi's. So these tabular form, we have values of xi's and yi's, x0, x1, x2, so on up to xn, and y0, y2, y1, y2, so on up to yn, n plus 1 points. Since there are n plus 1 values of x and y, therefore fx can be represented by a polynomial in x of degree n. Let the polynomial be of the form y is equal to fx is equal to a naught constant x minus x1 multiplied by x minus x2, so on x minus xn first term, plus a1 x minus x0 now. Then x minus x1 term is not here. Then x minus x2, so on up to x minus xn, plus so on up to an x minus x0, x minus x1, so on up to x minus xn minus 1. So this is our first equation of the polynomial of nth order. Now substitute x is equal to x naught, and obviously y becomes y naught. Then in equation 1 we get y naught is equal to a naught, x naught minus x1, x naught minus x2, so on x naught minus xn. Other terms become 0. So from this equation you can easily calculate the value of a naught in terms of y naught. Similarly, if you put x is equal to x1 and y is equal to y1 in equation 1, you will get value of a1 in terms of y1. And on proceeding the same way, we can find a2, a3 up to an. Substituting these values of ai's in equation 1, we get y is equal to fx, this whole is a0, x minus x1, x minus x2, x minus xn divided by x naught minus x1, x naught minus x2, x naught minus xn into y0. Similarly, plus a1, its value, into y1, plus so on an, this whole term is an, and yn. This is our equation number 2. And actually this is the Lagrangian interpolation formula. This formula can also be used to split the given function into partial fractions. How we can do that? Divide the above equation by this term x minus x0, x minus x1, so on up to x minus xn. What we get? Fx divided by this term is equal to this first term becomes y0 divided by x naught minus x1, x naught minus x2, x naught minus xn, okay, into 1 over x minus x naught. Other terms they will cancel out, okay, from numerator and denominator. Only this term is left. Similarly, plus y1 over x1 minus x0, x1 minus x2, so on x1 minus xn multiplied by 1 over x minus x1. Similarly, up to nth term. So this is the partial fraction of a given function, okay, of this function. Now let us consider an example that find the polynomial fx by using Lagrangian formula and hence find f of 3 for a given set of data. Value of x and fx are given, 0, 1, 2, 3, 5 are value of x, and 2, 3, 12, 147 respectively are value of fx. So for better understanding, I have denoted these values as x0, x1, x2, x3 and corresponding y0, y1, y2 and y3. Okay. Now to begin with, the intervals are not equally spaced. Now you see here the gap is 1 here, and again it is 1, and here it is 3. So we can apply Lagrangian formula here as well. So the Lagrangian formula is as we have already derived that formula in previous slide. So y is equal to fx, and this whole term a1 y0 plus a2 y1, so on, an yn, and we have substituted the value of a0 a1 an. Okay. So now, but in this numerical we have only values up to x3 or y3. So this example, for this example, the equation becomes so we have limit or substituted the value of n is equal to 3. So we have 4 terms, y0, y1, y2 and y3. So we have 4 terms and corresponding coefficients. Now if we substitute their values from this table, okay, substituting the value from the table data table, we get y is equal to fx, x minus 1, x minus 2, x minus 5 divided by 0 minus 1, 0 minus 2, 0 minus 5 into 2 plus for the other 3 terms. So if we substitute these values, we get that fx is equal to x cube plus x square minus x plus 2. So this is the formula uh, we got from the interpolation, and this formula reproduces the given data table. Okay. Now next is we have to find value of f of 3. So substitute x is equal to 3 here, and we simply find that f of 3 is 35. So value of x is given as 0, 1, 2 and 5, and we have found the value of f function or y at x is equal to 3 in between these two independent variables, values of x. So this is the interpolation. Okay. Let us consider another example that using Lagrangian formula express the function 3x squared plus x plus 1 divided by x minus 1 x into x minus 2 into x minus 3 as sum of partial fractions. Or we can also ask the question, express this function as sum of partial fraction without mentioning Lagrangian formula. So in example, so you have to judge by your own that which method will be applicable to this numerical. So let us start with the solution. Let us evaluate now. Consider y is equal to 3x squared plus x plus 1. Okay. Now for x is equal to 1, 2 and 3, we make a table that x is equal to 1, 2, 3, we get y of x, which is this one, becomes 5, 15 and 31 for respective x values. So denoted as x0, x1, x2 and y0, y1 and y2. Okay. Now Lagrangian formula for n is equal to 3, n is equal to up to 2 is x minus x1 by x minus x2 divided by x0 minus x1 x0 minus x2 into y0 plus other 2 terms similarly. Okay. So if we substitute the value from the data table, okay, from this data table, so I have substitute value of y0 as 5 and y1 as 15 and y2 as 31 and respective values of x0, x1 and x2. I get y is equal to 2.5 into x minus 2 into x minus 3 minus 15 x minus 1 into x minus 3 plus 15.5 x minus 1 into x minus 2. Okay. Now substitute the value of y on left hand side, 3x squared plus x plus 1, and after substituting the value of y, divide both sides by x minus 1, x minus 2, x minus 3, we get, so it is y 3x squared plus x plus 1 divided by x minus 1 into x minus 2 into x minus 3. So if we divide this whole right hand side by this x minus 1, x minus 2, x minus 3, so the two terms, they will cancel out from each term. So we'll get 2.5 over x minus 1 minus 15 over x minus 2 plus 15.5 over x minus 3. So we have expressed this term in terms of partial fractions using Lagrangian interpolation. So this is our required result. So in this video we have discussed about interpolation and approximation. We have discussed about the difference between the interpolation and fitting. We have discussed about various assumptions of interpolation and various methods like we have for interpolation Lagrangian method, Newton method, spline method, cubic spline, and least square method. And out of these methods, in this video we discussed the Lagrangian interpolation method of for unequal intervals. You can also apply it for equal intervals, but it is applicable to unequal intervals as well. And then we have studied how to write the function in terms of partial fractions using Lagrangian method. Okay. So in next video we'll discuss a Newton interpolation forward and backward formula. Okay. So thank you for watching this video.